In this video, we are going to cover the proof of the consistency of the OLS estimator. So we're going to use the simple linear regression model instead of the multiple linear regression model, but the proof is the same in both cases. So simple linear regression. So we know already that the estimator for the simple linear regression can be written in that form: beta 1 that we don't know plus sum of x minus x bar u minus u bar over sum of x minus x bar square. So we derived that in the video 2.3 about the unbiasedness of the slope estimator. So from this formula we're going to change it a little bit and add a 1 over n at the top and 1 over n at the bottom of this ratio, which doesn't change anything. But now that we have 1 over n of a sum of random variables, we are going to be able to use the law of large numbers. So for the top part, 1 over n, sum of x minus x bar times u minus u bar. This converges in probability toward the covariance of x and u. And 1 over n sum of x minus x bar square, so the bottom part of the ratio, converges in probability toward the variance of x. To understand both results, you can just look at the video about the law of large numbers. So see the video 5.3. Now, we know that the variance of x is greater than 0, and the covariance between x and u is equal to 0. If you don't know why, I'm just going to do a quick proof here. So we know that the covariance of x and u is, so I'm going to use the alternative formula for the covariance. So it could be written as the expectation of x times u minus the expectation of x times the expectation of u. And from the hypothesis, the assumption, from the assumption that the expectation of u given x is 0, if we apply the law of iterated expectation, we have the expectation of u equals 0. So we know that this part here is equal to 0. And the expectation of x times u, well, what is this? Let me take the expectation of x times u conditional on x and take the expectation of this. So by the law of iterated expectation, this double expectation is equal to the top part. Now I can take the x out of the expectation here because it's conditioned on x. So I have expectation of x times the expectation of u conditional on x. And I know this is 0 from our assumptions. So I have the expectation of x times 0, which is 0. So I just have 0 here. So I just proved that this part here is equal to 0. Now I have 0 minus something times 0. The covariance is 0. So to come back at our problem, we have beta 1 hat equals beta 1 plus this top part and this bottom part. And when n becomes very large, this top part goes to the covariance between x and u, which is 0. And this bottom part becomes the variance of x. So what does the ratio do? Well, this is the case alpha over beta that we covered in the video 5.2. The video is called Useful Facts. So beta 1 hat is equal to beta 1 plus 1 over n, the sum of x minus x bar, u minus u bar, over 1 over n sum of x minus x bar square, and this converges in probability to beta 1 plus the top part converges to the covariance between x and u, so 0, and the bottom part converges to the variance of x, which is equal to beta 1. So beta 1 hat converges in probability toward beta 1. Beta 1 hat is consistent. I hope this was clear. If you have questions, do not hesitate to leave a comment and tell me, oh, I have a question about this part at 0.1 minute and 30 seconds, and I will be glad to answer. See you soon!